Bienvenidos y muchas gracias por estar aquí esta tarde con nosotros. Tengo el placer de presentarles al profesor Anil Markandya, el conferenciante de hoy. El profesor Marcandya se doctoró en la London School of Economics y es catedrático emérito de la Universidad de Bath en el Reino Unido. Es uno de los autores, de los miembros más activos del IPCC, que, como saben, es el panel intergubernamental del cambio climático de la ONU, que fue galardonado con el Premio Nobel de la Paz en 2007. El profesor Marcandya es miembro del equipo que se encarga de la redacción del quinto informe del IPCC para el año 2014. También ha ocupado diversos cargos como investigador en prestigiosas universidades de ámbito internacional, tanto en Estados Unidos como en Europa. Podemos citar Princeton, Berkeley, Harvard o el University College en Londres. Es, como científico, como investigador, es autor de múltiples trabajos en materia de cambio climático, evaluación medioambiental, políticas medioambientales, energía y medio ambiente, contabilidad ecológica, macroeconomía y comercio. Recientemente, la Universidad de Cambridge le ha reconocido como uno de los 50 pensadores más influyentes de todo el mundo en materia de sostenibilidad. Por tanto, en estos días en los que se habla de investigación básica, orientada, transferencia, impacto social, impacto científico, pensamos que el profesor Marcandya es un excelente ejemplo de la combinación de la investigación académica reglada de rango internacional al más alto nivel y también del impacto de la transferencia de los resultados de esa investigación al tejido social, al desarrollo de políticas económicas, al desarrollo de políticas medioambientales, etc. Por tanto, en ese sentido, nuestro conferenciante de hoy es un investigador no recluido en su ámbito académico, sino con una labor de un gran impacto y que se resume en esa capacidad de influencia que le sitúa en la élite internacional en estos campos. Por tanto, para Euskadi es un gran activo, un gran honor que el profesor Marcandya ocupe en la actualidad el cargo de director científico en el Centro de Investigación BC3, que es el Back Center for Climate Change, impulsado por el Gobierno vasco y la Universidad del País Vasco en 2008, que está situado aquí en Bilbao, por cierto, bastante cerca del lugar donde nos encontramos hoy. Este centro trabaja en la línea con los aspectos que he comentado antes para ampliar nuestro conocimiento sobre las causas y los impactos del cambio climático, para poder así contribuir a impulsar avances que nos permitan anticipar, conocer y mitigar en la medida de lo posible y con sus pros y sus contras. No son temas de una sola variable, son aspectos en los que los pros y los contras deben combinarse de una manera muy juiciosa. Podría extenderme mucho más, pero yo creo que en este tipo de conferencias el importante aquí es el conferenciante y, por tanto, sin más, paso a darle la palabra. Professor Marcandya, welcome and thank you very much for coming. The floor is yours.
Muchas gracias, Fernando. Lo siento, pero hablaré en inglés, no en castellano. Es más fácil para mí. The talk today is about climate change, and I will be discussing the issues which we have been working on at the Basque Center for Climate Change, but also in a wider context, the problems that we have in trying to face this challenge, looking at it from our social and economic perspective, and not only from a scientific perspective. I'll talk a little bit about the nature of the problem, which I think most of you are familiar with, the kind of targets that we want to achieve to stabilize the climate, which many people now consider an important global challenge. How are there we have some concerns about policies to reduce emissions, how to make them effective. We'll talk a little bit about adaptation to climate change, which we also need to do, issues about rich and poor countries, and then offer some conclusions. Well, the climate change is very different from other challenges we have faced as a planet, and the reasons are three. Firstly, we have a lot of uncertainty about future impacts. We don't know exactly what will happen, but we have good reason to believe that we could have some very severe negative impacts. We also have a problem of dealing with the very long-term nature of the impacts, because what we do now will influence the nature of our planet for the next 100 and 200 years. There are not many things that we do which have such long-term effects. And the third is that there is a big divide between the rich and poor countries, both with respect to the responsibilities for climate change and the impacts of what climate change will do. Broadly speaking, the responsibilities for what we have now is due to the accumulation of greenhouse gases since the Industrial Revolution, most of which have come from the now developed countries, and the impacts of these changes, of this climate change, will be more severe in the developing countries. This graph shows, which is taken from an IPCC report, shows you the kind of problems that we are worried about with climate change. On the top axis we have the change in temperature relative to pre-industrial levels, and we are looking at ranges between 1 and 5 degrees Celsius. 5 degrees is a big change in climate in any region. And of course, while we have in some cases some positive effects for very small changes of 0 to 1 degree, or even possibly 2 degrees, as the temperature change goes up, the effects are mainly negative. So we have falling yields in crops, we have problems of significant fall in water availability, including in countries like Spain, and major problems of sea level rise as the temperature goes up. We have damages to ecosystems, and in terms of extreme weather events, we have a big concern about the rising intensity of storms, forest fires, and so on. And last of all, we have a big risk of abrupt and irreversible changes through events such as the melting of the ice caps and the dangerous feedbacks that these can cause. So this is the broad picture which brings us to concern about climate impacts. But we have also pictures which look and show you how much change there has been. So if you look at the coastal glaciers, this is 1941 and 2004 in the Muir Glacier in Alaska, and if that doesn't show a change of temperature or change of climate, I don't know what does. But of course, this is a period when global mean temperatures have not increased much. So we have pictures like this emerging from already the historical data that we have available. In 2003, we had a major European heat wave which caused very significant deaths in France and parts of Italy. Anomalies of temperature about 5 to 10 degrees above normal were observed in those countries. This is a graph which shows you the floods which we have observed since 1950 to 2009, and you can see that in every continent the number of flooding events has increased. In the Americas, in Europe, in Africa. The last decade in Africa had 415 floods, in the previous decades 152, and every decade before it was less. And in Asia it's the same. So these are the kinds of data, both historic data and the kind of predictions that we are getting from the scientists that lead us to serious concern about climate change. This is in a picture on droughts. We see that we have 400 million people who are now living under extreme drought conditions. And what land was classified as very dry in 1970 worldwide was about 15%. By 2010, it was 38%. Now, these are not things we can make up, and some people who are climate skeptics say we're exaggerating the possible impacts, but these are not exaggerations, these are historic data. So, what can we do about it? Well, this chart shows you what is the current situation in climate change can be measured in terms of the concentrations of greenhouse gases in what we call CO2 equivalent. And we have currently about 380 parts per million CO2 equivalent in the atmosphere. The expectation is that if we stabilize at 400 parts per million, we'll get a temperature increase of between 1 and 3 degrees. If we can stabilize at 450, the temperature increase could be between 1 and closer to 4. And if we can stabilize at 550, it's a little bit more, 650 a little bit more, and 750 we would expect anything between 2 and 6 degrees Celsius increase in temperature. Now the worrying thing is that we cannot stabilize at 400 because the current levels are already very close to that, and we still have huge increases in emissions being emitted into the atmosphere. So that's out of the question. But of the others, which target should we go for? Well, if we do no action, we could go well above 750, which would mean a range of temperature increase between 2 and 6, which is very risky. At the bottom end, it may be okay, but at the top end, it really would be catastrophic. So there is a current consensus in the scientific community, which says we should aim to stabilize greenhouse gas concentrations at around 450 parts per million by volume to avoid serious risks. Now, to do that will require global emissions to peak in 2020 and to decline thereafter. And notice that at the moment emissions are rising and there is no chance of meeting this target unless we take serious action. By 2050, emissions globally should be no more than 50% of their 2000 levels. And for developed countries, they probably need to fall by around 80% by 2050. So this is a big transition in the way in which we use energy and in the way in which we manage our agricultural systems, which are also responsible for significant emissions to the atmosphere. Can we achieve this target? And this question is asked. I believe yes is the answer, but the question then is at what cost? And the question then comes, who is going to make the required reductions in emissions? And these are some of the more difficult questions to answer in the context of climate change negotiations, as I will show you in my talk. In the following slides, I present some options based on some models which we have developed with colleagues in Europe, and particularly in France, and we've been working on them at our center. Well, the first thing is, can we justify this conclusion of the temperature of going for a 450 parts per million? And there are some people who say that it is too strict, it'll be too costly. Well, one major study which showed that this was justified was one that carried out by Stern, Nick Stern in the United Kingdom, who said that without a policy of emissions reductions, we will get significant losses of output. We'd have losses of between 5 to 20% of the world's GDP. At the same time, his study showed that the costs of achieving a 450 stabilization is about 1 to 2% of GDP. So in terms of what we call in economics a cost-benefit analysis, the argument is very clearly that we should go for this target, because the losses are much, much greater than the possible costs. In fact, the cost estimates are not uniform, and there are many studies that have been done in this area, And this graph shows you how much it would cost to reduce emissions relative to GDP. So on the vertical axis we have the change in GDP, on the horizontal axis the losses in GDP. And you see that the graphs are not, each point is a study. So each of those points is a large piece of work done by somebody to estimate the effects. And you can see here that for small changes, people think the cost is practically nothing. But once you get to changes of 40 or 50%, we have quite a wide range of costs. And this is why there is an element of uncertainty and an unwillingness in the parts of government sometimes to commit to these higher targets. It's one reason, but I'll give you another reason later. These are the figures that Stern's study showed. That he showed that if you start with, you have different scenarios of possible damages, because we don't know the exact damages either. There's a great deal of uncertainty. But we say that with no action, we could get damages of what we call market damages, damages to things that we produce and consume through buying and selling of goods, could be at 5%, but the range is very wide. It's from 0 to 12%. And in a higher scenario, it's between 7%, but the range again is 1 to 17%. And the impacts, if we include what we call the impactos más amplios, these are other effects through the environment, effects through here, which is a cause of great concern. There is another issue which arises with climate change, and that is that the estimates of damages are mostly after 2050 or 2060. So probably for the next 20 or 30 years, the expectation from climate change is that we will not have significant costs. The red line is the estimated mean cost of this from the studies. But once you get beyond 2070 and thereafter, the damages go up quite rapidly as a percentage of GDP. And of course the problem is that if we don't take action now, we are committed to this path of damages. And we cannot allow ourselves to leave future generations with those high damage costs. Now what happens is that when we do economic analysis, we tend to favor what happens now compared to what happens in the future. The way we do that is through something called discounting, and the danger is that with high discount rates, all of these damages are practically valued at zero. And that's one reason why the decisions on climate change need to take account of these longer term impacts through non-conventional methods of assessment. So why is policy on climate change so controversial? The damages are in the future while the costs incurred are now. So we are dealing with problems for the future, but we have to incur costs now to move to a low carbon trajectory. To get the present value of net damages to be positive, we have to take what are called very low discount rates. Stern takes a discount rate of 1%, but if you go and borrow money from the bank, you pay 7-8%, and even with these very low discount rates and market rates now, the banks will not lend for much less than that. So even for social projects, people take discount rates of 3 to 4%. The issue then becomes what discount rate to take. But there's another strand of thinking which says that maybe to decide on climate policy, we shouldn't just compare costs and benefits. We should look at these huge uncertainties and the risks that we are facing. And the problem is that not only is there uncertainty, but it's also not knowing the probabilities of these different outcomes. So we have the known unknowns, but we also have what's known as unknown unknowns. And the scientific community says going for the objective of 450 parts per million stabilization is really justified as buying us a reduced risk of catastrophic climate change. So that's what justifies it more than anything else. And this is a little graph which is produced at the MIT, which makes the decision in terms of a roulette wheel. So, we have the possibility of no policy. We have a roulette wheel where the probable changes of different temperatures are marked by these different areas. So we have a small change of 3 to 4 degrees Celsius with no action, a bigger possibility of 4 to 5, an even bigger possibility of 5 to 6, and then smaller possibilities of 6 to 7 or more than 7. Now, if we go for our stabilization target, we still have a some chance that we'll be between 1 and 2 degrees, a bigger chance that we'll be between 2 and 2.5 degrees, and it's quite a big chance of 2 to 3, but a small chance of 3 to 4. Now the question is, which roulette wheel would you want to play? And of course, if you want to play the roulette wheel on the left, then you're a great gambler. You're gambling very severely. If you want to play the roulette wheel on the right, you have to take some actions now. And these are the actions that we're describing here. So the policies are available, and one of the main targets now is to see if we can reduce emissions by 50%, halve them by 2050. We can do that, but we need a combination of economic instruments and policies, but also a lot of research and development in innovation. So we have here what is the difference between the BAU, which is the business as usual path, and the path we need to be on, which is this one down here. So we need to eliminate all these emissions. And Sokolow at Princeton has divided these emissions into little pieces, slices, and he has identified policies that can help us or technological changes that can help us to meet those policies. So there are some things like energy efficiency and energy savings, which are a relatively low-cost way of achieving reductions. They account for like 1/3 of all energy consumed in Spain, for example. If we substitute coal with gas, if we can convince ourselves to use nuclear energy, that's a relatively low-cost way of achieving a reduction. Wind and solar energy is a bit more expensive. And then we have biofuels for transport, which are also a bit more expensive, or could be these two roughly have similar costs. And then we have more speculative, more difficult technologies, such as carbon capture and storage, where we take the carbon that is emitted and reinsert it back into the earth, into the ground, which means it doesn't have a climatic effect. We have developments of hydrogen-based energy, and we have vehicles which could be electric vehicles, and then possibly use of hydrogen for transport. So we have to go down this whole list, and all of these will be needed in due course, but it's better to start with the cheaper ones which are up front. So what will this do? It will mean energy will cost more, but the increases need not be so large, and if the plan is exercised carefully. And the increases in research and development will have to be funded by cutting other budgets. So how much we have to pay to buy emissions rights will depend also on how we allocate these emission rights, and I'll come to that later. But these are all issues which will determine the costs. But the last thing is that the costs of meeting the target could be reduced significantly if we could avoid deforestation. Because at the moment about 17% of our emissions come from agriculture, and another 15% or 16% come from loss of forests. So if we can avoid deforestation, the costs from other sources will decline. There's another thing which I believe is important, is that to achieve these targets, it's really helpful to have the use of some economic instruments like a carbon tax or emissions trading. Now most models indicate that the most effective way of achieving a reduction is through a carbon tax or through an emissions trading scheme like the one that the European Union has initiated for 5 years ago. Other policies such as research and development subsidies are important, but a carbon tax creates a carbon price, which is critical to the transition to low carbon. And this just shows you, for example, what would be involved in the case of Spain. If we look here, we have what would happen with no policies. This would be the situation in 2030. We would have about half of our energy coming from oil, about 17% from coal and lignite, 23% from gas, and then small amounts from other sources. I'm not sure whether these are still, how valid these will remain, but this was when we did the first analysis. And there is there's a small role for nuclear, some for wind and solar. Now, to achieve the 50% global reduction, what we would expect, the big change comes from quite a big reduction in oil, an increase in the role of natural gas, no big changes in nuclear, but perhaps in biomass, but perhaps a slightly bigger role for nuclear, and a much smaller role for coal and lignite. But what's important is that with this mixture, we need to sequester, we need to capture some of the carbon. And so in this situation, we would expect that you would need carbon capture and storage, and that is still not a proven technology. So to achieve this transition is still questionable as to whether it can be achieved. This is just the same picture for a bigger country, China, and you can see here also that the transition involves a big reduction in coal, but here there's a bigger role for things like wind and solar, some increases in hydro, geothermal, nuclear, and increases in natural gas, reduction in the role of oil. But again, to achieve that 50% reduction target globally, China would also need to have a bigger role for carbon capture and storage, which is, as I said, not a proven technology. This just shows you what is involved in the changes. People are worried about the kind of carbon tax, how much it will cost. Will it raise the price of fuels and petrol and gasoline and so on? And this is the baseline assumption. At the moment, we start with around, I say, about €1 per litre. In fact, it's more than €1 now. Gasoline costs, what, about €1.30 or something like that, a bit more. If it was €1 now, by 2020, in the baseline case, it would go up to about €1.25. With our policy of trying to achieve this global target, it would go to 143. In 2030, the price without any policy may be up to about 142. With the policy of climate change, meeting the climate target, it might go up to about 180. Now, I know this is an increase, but in 2030, we hope that there will be a lot of much cheaper, much better alternatives for transport than using a car which uses gasoline. So this is to provide the incentive to move to lower carbon fuels. We also need to take account of non-carbon energy sources, and this just explains to you how the picture looks now. I mentioned forestry and deforestation. It's about 17% actually. Agriculture is 14%. So we need to do something to reduce emissions here as well, and not only to focus on energy supply, transport, and industry. So here, the non-carbon energy sources, we ourselves are undertaking research on how to reduce emissions from terrestrial sources, but probably the most important one at the moment is deforestation. And if we can reduce such deforestation, we can make it much easier to achieve this target of 450 parts per million. And the program to reduce deforestation is referred to as RED, the reductions in emissions by reduced deforestation. And this just shows you how much it would reduce the costs. It's not clear, it depends what database you take, but if we could include a RED program, which involves countries like Brazil, Indonesia, the Congo and countries which are undergoing significant deforestation, the cost to us of meeting the target could be reduced between 12 and 25%. These are different data sources and emissions from deforestation. The problem here is that to do this, we have to get an agreement to pay these people not to deforest, because they say that they're deforesting because they need the people who live on the land need the land for agricultural and other uses. So we need to have a program which would pay them, and if we could do that, it would be a lot cheaper overall. If we had a RED program, it would also help us to reduce the carbon prices that I mentioned earlier. Not much, but a little bit. And whether they reduce much or not depends on whether we have something called banking, so that we could, if we had bought emissions rights, whether we could save them for the future. This is a little bit technical, but it shows you that we could also reduce the cost through this reduction in carbon prices. And if we have a RED program, one of the things is, will it displace the deployment of low carbon technology? And we show that it reduces investments in renewable power by about 2% to 5%. So it's a very important policy component of our possible solutions. And at the moment we're making a little bit of progress on it. There is almost agreement in the global community that we should include it. But of course we don't have a global agreement, so there is nothing to which this RED program could currently be attached. Then there are several implications of all this, because if we are going to go for this sort of program, we need implications for investments. So the targets that I've described can be met, but we have to finance these investments. And the investments involved are huge, quite large sums of money. So the Agencia Internacional de la Energía, which is based in Paris, estimates that we need to current investment in energy that is needed is about 250 billion between 2010 and 2030. And then it goes up to about 936 billion between 2020 and 2030 to achieve the target. Now in this we have to make a lot of investments in energy efficiency, but we also need to make investments in renewable energy. Now this is not so high, because the global figure is only about 0.3% of global GDP, and as of 2010, and will be about 0.7% of global GDP in 2030. So in that sense it's not so high, but it is high when you think that at present the developing countries need about 190 billion a year, and their current level of finance is only 80 billion. So we still have a big gap in terms of investment that we need to fill to meet this condition, to achieve this transition. So we need investments in big areas here: wind, solar, biomass. And where is this going to come from? Well, in a way, this is also a chance, an opportunity for the private sector to try to make investments, to get returns. But it can only do that if the public sector provides the right incentives and the right framework. And including in that framework is the role for a carbon tax. So let me now turn to the next issue, which is the question of rich and poor countries. And the question is that we know that rich countries will have to make a bigger sacrifice to meet the climate objectives. I think broadly there is agreement. But by and large, the poor countries are more negatively affected by climate change. Although, I mean, some places like Northern Europe may even get some benefits from climate change in the next decade or so. But at the same time, we cannot achieve this goal of a stabilization at 450 unless all the poor countries also reduce emissions. And then in the debate that's been in the political arena, the developing countries have been complaining that the problem we have now arises because rich countries carry a debt of responsibility for the current greenhouse gas concentrations. So the point they make is like this: even now, if you look at the emissions per head, the United States is up here, we in Europe are down here. China has gone up a lot. It's not here. Since even this was produced about 2 or 3 years ago, its emissions per head are higher. A country like India is down here, and other non-Annex 1, which are developing countries, are here. So we don't have a. If you take the whole area, that gives you the total level of emissions, but the height gives you the emissions per capita. And here we see what is the nature of the political problem, because there is great inequality in terms of these emissions. So how can we allocate what emission rights we have? Well, it's very difficult to say we shouldn't allocate them based on a rule which says that every one of us has the same rights. So each person is allocated one right or 2 rights or whatever number there are. If we do it this way, then even current levels of emissions, the developed countries will have to buy a large number of rights from developing countries. Now, some people say we should go even further back and allocate them based not on population, but also applied to historic emissions, because so much of the carbon space that we had has been used up. And if we do that, then developed countries would have to buy even more rights. But this is all this is if you like, a debate, a social debate. No country really would accept, no developed country would accept to go for this kind of solution. Although there may be some ways in which we might agree on future allocations based on population. And here is a little picture which shows you what would be involved. Supposing we did agree that emissions should be allocated based on population. And I show you the picture by 2020 and 2030 of the emissions that we would expect in these countries based on some kind of path towards a climate agreement. So China, for example, by 2030 would have about 6.8 billion tons. Based on population, it would be allowed only 5.3 billion tons. So even a country like China would be buying the rights from other countries that are not using their full quota. India in particular, we expect its emissions to be about 1.8 billion, 1.9 billion, but on its population basis it would be allocated 5.1 billion. So it could sell about 137 billion euros worth of rights. Now in Europe, we would have we expect emissions in 2030 to 2020 to be about 3.6 billion, but our allowance, based on this rule that we allocate equally to all the people in the world, would be about 1.9 billion. So we would be net purchasers, for which you'd have to pay 72 billion. While that's not such a large amount, if we think that we make payments already through programs such as aid and other development programs, so it may be possible to get an agreement of this kind. But it's not easy. And the amount goes up when we get to 2030, when the reductions that we need in emissions are even greater. So in our model, we find that India, China, and the European Union would have to buy significant rights. The European Union would have to pay 27 billion, which is about 150 euros per person in 2020. And in the total overseas development assistance, which was given to poor countries in 2007, was 80 billion. So these figures are roughly comparable. And the problems that we've had in the negotiations, particularly in Copenhagen and subsequently, was on how to allocate these rights. And it was clear at those meetings that the European Union and other rich countries will not agree to fully agree to these kinds of transfers. So that is one reason why we have a problem in terms of emissions rights. So what is the way forward here? Well, we have a problem. Each country or region makes its own commitments to greenhouse gas reduction, which is what is happening. But if that happens, we cannot be sure to achieve this 450 target. Or the developing countries accept bigger reduction targets than their rights would justify, but under major increases in either overseas development assistance, technology transfer, or funding for what we call adaptation. Now this is possible, but and some of the negotiations are going in that direction towards finding a solution. But again, there are many gaps still to fill. Talking about adaptation, let me say a few words about this before I close, that even if we achieve the 2 degrees Celsius stabilization target, which is the target which goes with the 450 ppm, although remember 2 degrees is not guaranteed. You remember that roulette wheel, it could be between 1 and 4 degrees. But in this case, we will still need to adapt to climate change, because a 2 degrees Celsius change in the Basque Country, for example, will give you a very different climate and a very different landscape, agriculture, land use, and so on, than you have now. And these adaptations will be needed in several areas, including relating to health, sea level rise, freshwater systems, extreme events, infrastructure, agriculture, ecosystems, and sectors like tourism. And we've been doing a lot of work to try and understand this better, but the estimates show that the costs expected to achieve this adaptation, if we look at the developing countries, are in this range. We're looking about 80 to 100 billion a year for the adaptation alone. And there is a sense in which the discussions and negotiations in international agreements have been now to see how we can develop a fund which will help these countries to adapt and make this money available. And this will be funding essentially coming from the developed to the developing countries. But even developed countries, even richer countries, need to spend money, and we have a budget, made some estimates of the budgets required. So the current situation is that there's commitment in principle to a fund of around 100 billion for adaptation, but although there's principle, but the actual amounts which are been allocated are much less than that. The problem is it's difficult to separate this kind of finance from what we call development finance, where countries are getting some support for their development programs, what we call overseas development assistance. And development definitely makes countries more resilient to climate change. So some people say the best way to adapt for these poorer countries is to grow faster. So by growing, they will become more able to cope. For example, we look now, every time there is a big extreme event or a rise in sea level, or extreme event like Katrina in the United States, the number of people who were affected, who died, was small. The similar event in Bangladesh results in thousands of people being killed. So the problem is partly addressed through making Bangladesh a richer, country more able to cope with adaptation, with climate change. So currently we have a problem. We're trying to develop programs to try to estimate the costs and the damages. And although a lot of countries are working at their individual level, but we also have international action needed in special areas like disaster response, in developing crop varieties and technology, and in better forecasting of climate and weather. So what has been achieved in recent meetings of the climate negotiations? On the positive side, we've had some agreement on this Green Climate Fund, which is intended to raise 100 billion, which is a lot of money, but it's still not fully negotiated. There are some parameters for reducing emissions from deforestation, which are this RED program, and that also looks positive. There's some transferring of technology discussions between the North and the South. But there has been some progress in monitoring and verification associated with deforestation, which is very important. And another important issue is that we had until this year, a small agreement called the Kyoto Protocol, which was a framework which did allow countries to commit to some reductions, and which also provided a way for poorer countries to participate in the reduction program. So whether this can be extended is beyond 2012 is still an open question. On the not so positive side, we still have no legally binding agreement, And the voluntary commitments amount to much less than what is needed to stabilize at 450. And there's still discussion that Japan and Russia will not participate in the new Kyoto Agreement unless China and the US join, and we have no sign that they will at the moment. So let me conclude to say that climate change is our most serious of our challenges, I think, facing us today. The impacts of climate change affect all areas of society as well as the environment. There remain huge uncertainties regarding level and impacts of climate change that need to be accounted for in the design of policy. To reduce impacts of climate change, it is very important to reduce emissions of greenhouse gases. And the costs of not acting to reduce and stabilize concentrations are much greater than the costs of mitigation from what we can see. We need, however, to increase our knowledge, and the role of new innovation is very important, but the need for knowledge is not an excuse for lack of action. We must start and move to this path towards 450. We should try to make our action as flexible as possible, and a carbon tax is a very flexible instrument. And we need to get some agreements with cuts by all parties, not just the rich countries, but rich and poor. And we need to take some action on adaptation. If all this happens, I think we have a reasonable chance of making some progress. But at the moment, the glass is half full or half empty. Thank you very much.
Thank you very much, Professor Marcandya, for this outstanding and clear, even for a non-expert audience, lecture. The forum is open for questions. Pueden hacer preguntas. El profesor Marcandya comprende las preguntas en castellano y contestará en inglés. O sea que tenemos tiempo para unas cuantas preguntillas.
¿Me oye? Sí, vale. Que yo quería preguntar, que no he entendido muy bien, o qué puede ser cuando hablaba de carbon capture storage o algo así. Era como una tecnología que capturara el carbono, pero no se me ocurre qué puede ser eso.
Well, you know, it also worries me a bit about how important a role carbon capture and storage has in these scenarios and the different models that we have used to try to understand how we can achieve this target. And it's also true that we have only a few pilot projects at the moment with carbon capture and storage. There are many issues which have not been resolved, including legal issues, possible accidents which could occur if emissions, you put the carbon CO2 in and there is an eruption which could cause an accident. So the technology is not fully developed, but at the moment it has a very big role in the solutions. And the only thing I can say is that we need to build the research program much more rapidly. We need to check this possibility much more carefully. There is also one other option which I didn't mention, which is called geoengineering, which is now also being discussed a little bit more seriously, although not that seriously. And the idea is to inject sulfur into the troposphere, so that we have a much the greenhouse gas effect is eliminated by the radiative forcing being reduced through this effect. And this also is a program which may get some research. I'm even more against that than I would be against carbon capture and storage. To give our planet a kind of a sulfur drug like this doesn't seem to me the right way to address climate change.
Concerning this problem, relativo a este problema como químico, as a chemist, I know that there are ongoing projects on the transformation of carbon dioxide, this is of course a gas, into a solid chemical compounds, much more, in order to store these materials more easily. What are you aware? Do you include in this, in your analysis, this kind of transformations into solid residues?
Well, that's one step even further removed from the current. The estimates we have are based on what we can see from the re-injection at the moment. We haven't used the solid because the figures are even more uncertain for that. But you know, we don't know. Maybe in the near future somebody will develop something more effective like this, which will help us to solve the problem. This is why a lot of people place a great deal of importance on research and innovation in this area. Many of the things on which we are relying to solve the problem are still not fully developed as yet, and we need to make big strides and improvements in this area.
¿Una otra pregunta?
Sí, buenas tardes. Me gustaría hacerlo en inglés, pero el nivel no es tanto, así que en castellano, ¿vale? La pregunta era si teníais también pensado, bueno, dentro del BC3, políticas de decrecimiento o políticas que aboguen igual por disminuir las emisiones desde un punto de vista de la producción, de producir menos. O sea, no ya tanto de abogar por tecnologías como el hidrógeno o otro tipo de tecnologías que sean punteras y reducirlo a través de la eficiencia, sino eliminar la eficiencia como modelo de reducción y abogar por reducir directamente a través de la bioconstrucción o reduciendo directamente el tráfico o... Pregunta.
His question is about in order to reduce not only the rise for the emissions, but the emissions themselves.
Yes.
By reducing the traffic, for instance.
Well, you know, we have it. You're raising an interesting question because the projections that we are basing a lot of the models on take us assume some growth in the economy, and this growth in the economy, even in our region, means that by 2050 and 2100, the level of incomes will be higher. Now, of course, we've done some work to see how much difference it makes if that growth is smaller. And it does make it easier to achieve the target if we don't have high growth as if we do have high growth. Of course, at the same time, we can see what happens in an economy if we cannot have a little bit of growth, like you're seeing now in Spain, where we have a little negative growth and the whole economic situation is in some crisis. So we need some growth in the economy to sustain the economic structures, but we don't need quite as high a rate of growth. The other factor which also helps to reduce the cost of achieving the target is population growth. So it's not only people consuming more, but more people. So both of these, of course, the population growth, at least for the next 20 to 30 years, is beyond our control because it's determined by the inertia of the existing birth rates. But if birth rates decline over time, then that also would help to reduce the pressures or the costs of meeting the targets. So you're right. We don't necessarily want to see increases in output in all areas, but we want to see reductions in some areas, particularly those which are what we call high carbon or high carbon using, like transport. We would like to see transport being moved to a much lower carbon, either lower carbon base or less travel, people just using it less.
¿Alguna otra pregunta? Pues si no, muchas gracias otra vez, profesor Marcandya, y muchas gracias a ustedes por haber venido en una fecha tan señalada.
Sí.
Muchísimas gracias.